Now we will start with the module 4. So op-amp with the negative feedback and general applications. So in that, first topic is inverting and non-inverting amplifiers. So start with the introduction part. Before starting with the topic, just to know what is op-amp. Op-amp is nothing but operational amplifier. It is defined as it is basically an excellent high gain DC amplifier. So here it performs the amplification for a DC gain. So the operations performed by the op-amp are like addition, subtraction, multiplication, integration, differentiation, etc. can be done using operational amplifier. Now look at the symbol here. In the symbol of the op-amp, it contains 5 terminals. 2 are input, 2 are dual power supply, and 1 is output terminal. Okay. Now I will explain the importance of the terminals which are used in the symbol. So I am just refreshing it because I am going to use this op-amp in the derivations. Now, first I will start with the inverting amplifier or inverting terminal. So inverting terminal is connected to the negative sign. Non-inverting terminal is connected to the positive sign. It indicates that negative sign means it provides 180-degree phase shift between the input and output. Positive sign means it generates 0-degree phase shift between the input and output. For example, we will consider like this. If what I will do here, if I connect a V in to this terminal, connect V in for this, provided with this to ground, then here the output V0 we will get like this. So this is the input and here the output should be 180-degree phase shift like this. So comparing input and output, there is a 180-degree phase shift, hence it is called as inverting terminal, and the amplification performed is called as inverting amplifier. Similarly for non-inverting here, so this should be provided with ground, V in here, we get the V0. The only change here is the output with respect to input has no phase shift. If this is an input, we will get the output, only it is amplified, okay, but the phase remains same, hence it is non-inverting, means there is no inversion here. Non-inverting terminal with respect to input and output. So this is about the basic symbol. These two are dual power supplies to turn on the op-amp, and this is V0 to measure the output. Now we'll focus on the next thing, that is characteristics of op-amp. In the characteristics of op-amp, some important characteristics I have mentioned here, like infinite voltage gain. This is very important because op-amp has high voltage gain, high DC voltage gain, which is the definition itself says there. So here for theoretically we will assume it as infinite. Similarly, it has high or infinite input impedance and bandwidth, common mode rejection ratio, slew rate, 0 output impedance. So these are some characteristics of op-amp. I am just refreshing them so that we can utilize in the derivation. Okay. So the important point is voltage gain, which is very high here, that is infinite for theoretically. Practically it has certain value which is very high. So now we will move on according to the syllabus. In that, the first topic is practical non-inverting amplifier. Okay. So practical non-inverting amplifier, in other terms it is called as voltage series feedback amplifier. Remember this. So both are same here. I am using this voltage series feedback amplifier is already discussed in the feedback topologies and this block diagram which I have shown there. The same thing we are going to consider here. And other important points which are going to discuss in this non-inverting amplifier, that is voltage series, are negative feedback. What is the effect of negative feedback to the input side? Closed loop voltage gain, means the voltage closed loop means if there is a feedback connected from the output to the input side. And here for non-inverting amplifier, this I think you already remember this, AF equals to 1 plus RF by R1, where RF is the feedback resistor, R1 is the input resistor. AF is the closed loop voltage gain feedback. Okay. So this we already discussed in the basic electronics also. That's why I written directly some formulas just to refresh them. Here input resistance or impedance RIF, that depends on the input resistance 1 plus A beta. This I am going to derive in the coming topic. Similarly, output impedance ROF means feedback, output resistance with feedback. R0 means without feedback. That's it, that resistance. This is bandwidth. FF indicates frequency with feedback is always equals to 1 plus A beta into F0. F0 means frequency without feedback of the input and output respectively. So these are the topics which comes under practical non-inverting amplifier. So now we'll discuss one by one in the practical non-inverting amplifier. Okay.